Dear student, welcome to the part 5th of lecture series of molecular beam epitaxy. In this lecture, we will discuss about the internal design of molecular beam epitaxy system. Dear student, please note that molecular beam epitaxy system is very complicated system because it is based on combination of multi-vacuum pumping system, and it is also based of combination of multi-chamber used for precursor and also multi-characterization system. So MBE is basically a multi technique system. Okay, so it is very complex technique, but in this lecture I will explain with this in a very easy way with the schematic diagram. So this lecture is basically limited to MBE system with limited characterization and vacuum based systems. Although in a real sense MBE system can be more complicated than the system which I am presenting here. The MBE system is basically composed of a reaction chamber. Okay, this is the chamber in which the MBE system is basically is based, and this chamber is connected with high vacuum pumping systems. Okay, so this chamber is basically of molecular epitaxy is evacuated, and high vacuum is basically created by using multi pump vacuum pumping system. Due to this, in this schematic diagram I have represented two different types of pumping system. Okay, so these are two different kind of pumping system which are basically creating ultra high vacuum pumping. As you know that the vacuum used in MBE is quite high, and it is around 10 raised to power minus 8 to 10 raised to power minus 10 torr, which is so high. So the combination of the multi pumps are basically used in molecular beam epitaxy in order to create high vacuum inside the reaction chamber of the molecular beam epitaxy system. Dear student, please note that MBE do not use the pumping system which use oil for creating the vacuum, such as diffusion pump or rotary pump, because usually in the diffusion pump the vacuum is basically created due to the uh, evaporation, or due to the oil, and that oil basically the vapor of oil basically can create an impurity in the epitaxial layer, and that can basically damage the deposited epitaxial thin film. So due to this, different types of pumping system, apart from those pumping system which use the oil, are not used in molecular beam epitaxy system. Please note that usually in MBE, turbomolecular pump, ion sublimation pump, and cryo pumps are used. However, the combination of cryo pump with other pump is most common in MBE, because the cryo pump basically works at very low temperature, somewhere around minus 170 degrees centigrade, which is low temperature. So that low temperature also act as a sink if there is present any impurity. So the cryo pump is low temperature is sink to the impurity, and it can basically take away the impurity from the reaction chamber. This reaction chamber of molecular beam system is also connected with load lock system. Okay, dear student, what do you think what the term load lock mean? Please note that system with this load lock system, the sample or the precursor which we want to deposit as a thin film is introduced inside the reaction chamber. What do you think? What's the term load lock mean? Or chamber, it's a load lock system. And what's the term load lock mean? Load lock is basically a locking of the precursor material in conjunction with the MBE reactor. Since you know that the pressure inside the MBE reactor is quite high, and it is not possible to introduce precursor again and again by decreasing the by decreasing the vapor and by decreasing the vacuum. Okay, so basically the load lock system and chamber lock system control the vacuum. Okay, there is a kind of disc in the chamber loading setup, or the load lock setup, and that is basically flips, and the samples are in the precursor form. The precursor are basically somewhere inside the chamber loading setup, which is a load lock setup. And if like we want to deposit the precursor material from the chamber loaded setup, that the ring basically flips, and it's basically turned and switched inside the reaction chamber. So in this way, the vacuum of the reactor don't break with the environment of the chamber loading setup. So basically chamber loading setup in the molecular beam epitaxy is load locked, and it is there are the kind of rings between the load lock or the chamber loading setup and the reactor, and these rings basically flip and turn the precursor material inside the chamber of the molecular beam epitaxy, and to do this the vacuum maintained. Please note that if the vacuum decreases, or if we basically if our samples which are our precursor materials are free to the external environment, and they are introduced inside the reaction chamber, so there is a possibility of decrease in the high vacuum, and it's become quite difficult for molecular beam epitaxy to create the vacuum pressure 10 raised to the power -8 to 10 raised to the minus 10 torr again. So due to this, the chamber loading setup in the molecular beam epitaxy is load locked, and the ring or the flipping ring is used between the chamber loading setup and molecular beam epitaxy reaction chamber, and with that ring flips and turn, and the precursor which is present somewhere in the chamber loading setup is introduced inside the reaction chamber, and they basically don't break any kind of the high vacuum, and the molecular beam epitaxy become more realistic. Inside the reaction chamber of molecular beam epitaxy, there is a stage, okay, and on this stage usually the source material is present somewhere in the crucible of the molecular beam epitaxy. So this is the source material. The source material is a material which we want to deposit, okay. Source material is also present in the chamber loading setup, and it is also present inside the MBE system for deposition. So the source material which is present in the chamber loading system is usually not used for deposition. In case if we want to deposit multi kind of component system, then we can basically flip and introduce also the chamber loaded source material, and in the presence of the source material which is in the crucible of the MBE. So please note that, student, the source material is present in the inside the reaction chamber of the molecular beam epitaxy, is basically introduced before creating the vacuum pressure inside the reaction chamber of the molecular beam epitaxy. Okay, so this after introducing the source material, the vacuum is created. So this is basically introduced from the outside, whereas the other chamber load materials basically are also introduces from outside, but they are present during the reaction, and they are basically They are basically inside the chamber loaded setup. So the source, and it's also please note that it's not important that MBE use one source material at the same time. Let's say if we want to deposit gallium aluminum arsenide, there is a possibility that MBE reaction chamber have gallium container having a gallium source material, another container having an aluminium source material, and third container having a arsenide source material in the form of a solid in solid powder form. So for MBE, because the complication of this technique, there is a possibility that MBE system or MBE reaction chamber have all those precursors, like multi type of precursor or material inside the reaction chamber, and they are present inside the bolt of the inside the bolt and inside on in the reaction chamber. So another aspect to notice here is that source material is usually placed in MBE in a bolt material. This is the bolt in which the source material is present. The bolt material have in MBE used have a higher melting point, because if the melting point of the bolt material is less or closer to the source material, there is a possibility when we want to evaporate the source material, there is a possibility that incorporation of the container or and the impurity of the bolt into the source material. So the bolt used in MBE is usually have a high melting point, and usually the pyrolytic boron nitride is basically used in molecular beam epitaxy. Now the question here is that how the source material inside the reaction chamber of MBE is evaporated. Basically, there in the stage of the MBE there is a setup which is for the electron beam evaporation. Okay, so the electron gun is basically present inside the molecular beam epitaxy reaction chamber. This electron gun is connected with magnetic poles. Okay, so when the filament basically is heated, and that basically generate the electron in the electron gun, can go straight in the straight path. But since you know that the magnetic poles basically interact with the electron, which are basically moving in a straight path, and due to this the electron basically turned in a circular path, and they are directed onto the in a circular path, and they are directed onto the source material. So basically the electron gun in conjunction with magnetic poles basically act as an electromagnetic wave. Okay, so basically the magnetic field which is basically introduced by the magnetic pole basically cause the spiralation. Okay, they cause the circular motion of the electron beam, whereas the electrons have an electric charges which are produced via electron gun. That electric charges, and they have negative charge, so the negative charge, due to negative charge, they have electric field. Okay, and the electric field direction is in the straight path. Okay, just like this, whereas due to the magnetic field, the electrons basically spiralate, and they move in they basically deflect, and they move they try to move in a circular path. Due to this, the electron gun which are basically electron beam are basically deflected and directed onto this source material. So there are some important facts just to note, that the electron beam which is introduced on the source material inside the reaction chamber of molecular beam epitaxy must focus at certain point on the source material to evaporate this source material. Okay, So if the direction of the electron beam is not focused and it is somewhere near the bolt in which the source material is placed, then there is a possibility of the incorporation of the bolt material into the in place of the source material onto the substrate, which can basically cause an impurity. Okay, so the electron beam must be focused on to the source material in molecular epitaxy setup. Okay, and due to this electron beam, the source material start to evaporate. Now question here is that the source material start abruptly evaporation, and we are talking about molecular beam epitaxy. We are talking about the controlling of evaporation of dopant material at molecular level. Then how the evaporated source material is controlled and it is transported onto the surface of the substrate at molecular level. This is done by introducing electronically controlled shutter. Basically, these shutters are controlled by a microprocessor, and the precursor material, this precursor material, which is transported, it is transported in a at a very small time scale. So basically the shutter open for, let's say, for a few milliseconds, and then it's closed. So in this way, very small amount of the precursor molecule is transported onto the substrate surface. So the shutter in the molecular beam epitaxy play a vital role in order to control the epitaxial growth at layer by layer at molecular level. So now the MBE system consists of a substrate holding system. Okay, this is the substrate holder in which the substrate is basically incorporated. Okay, and the substrate, basically the substrate holder, okay, this is substrate holder is basically is connected with a heating setup. Just please note that in MBE the substrate is heated. The reason of heating the substrate is basically if the uniform deposition of the precursor material, because of the heating of this substrate basically create and first desorption of if there is any kind of liquid phase impurity present, and secondly that basically act as a uniformity in the deposition of the thin film. Another aspect to note is that, dear student, there usually in some MBE system the substrate is basically also rotated. Okay, so there is a rotational system in some MBE system, and due to the rotation of the substrate, the film basically uniformly deposited over the whole substrate. If the substrate is static, then there is a possibility that the source material is basically deposited somewhere in a different way, in a gradient fashion, and at a different place. So in order to get more uniform thin film, the substrate is basically rotated, and this way we can get highly uniform thin films. The heaters basically used in MBE system are connected with a water cooling system, so that's basically cool the substrate if the substrate is heated too much. Usually, dear student, please note that the heater used in MBA system heat the substrate somewhere around 200 degrees centigrade, whereas the source material have usually temperature around 800 degrees centigrade. Please note that if we want to deposit a silicon based thin film via molecular beam epitaxy, the melting temperature of silicon is too high. It's around 1400 degrees centigrade. So that can basically there can be a very high temperature inside. For since the MBE is a low temperature based technique, so that due to this the electron beam evaporation is more common to evaporate the material which has a high melting point like silicon. So another aspect to note here is that the shutter is also present in MBE system above the source material. Okay, so first it's also present near the substrate material, and it's also present above the source material. So both those shutters basically electronically connected with microprocessor, and they basically control both the evaporated material from the source material and also the interaction of the source material onto the substrates. And in this way basically this technique give us the window of opportunity to deposit the film at molecular level. Now question here is that the student, usually in MBE system they basically use different kind of dopant. Okay, basically the thin film fabricated by molecular beam epitaxy have wide range of dopant. Like if we want to prepare P and N type of dopant using molecular beam epitaxy, there is a setup which is based on Effusion cell is used to introduce a dopant onto the surface of the substrate in MBE epitaxial thin films. So the dopant material is basically present inside the Effusion cell of the molecular beam epitaxy setup. Okay, and the Effusion cell is also connected with electronically controlled shutter. So this shutter basically control the evaporation of the dopant, and like electronically it is controlled. So on this way we can also control the amount of dopant which we need to incorporate onto the surface of the substrate of the molecular beam epitaxy setup. So the Effusion cell is used to incorporate the dopant in the molecular beam epitaxy setup. Student, please note that Effusion cell is based on inductive systems. So it is based on induction coils, and the induction coils basically thermally evaporate the dopant which is present somewhere inside the Effusion cell, and this dopant is basically after the thermal induction, the dopant is basically evaporated and transported onto the surface of the substrate. Please note that the molecular beam epitaxy, the deposition of the thin film is monitored even with the naked eyes. Like there are some point in the reaction chamber through which we can basically visualize with the naked eyes that what is going on inside the reaction chamber of the molecular beam epitaxy setup. Now coming toward the additional setup which are basically used in molecular beam epitaxy systems. Dear students, please note that molecular beam epitaxy system usually consists of ion implantation setup. Usually the dopant is introduced in MBE via Effusion cell, which is based on thermionic emission. So the dopant is thermally evaporated and transported onto the surface of the substrate. But this technique has many drawbacks. There is a possibility of incorporation of impurity from the Effusion cell, and secondly, higher temperature is also required in Effusion cell setup. So MBE system is also equipped with ion implantation setup. Okay, with this ion implantation setup, basically the dopant is basically transported evaporated and transported onto the surface of the substrate. Listener, please note that the dopant introduced via ion implantation is more uniform than the dopant introduced via the Effusion cell. As I previously discussed, MBE is a multi-component system. It consists of many types of characterization setup and as well as many types of vacuum-based system. So there is also another setup in MBE which is most common in molecular beam epitaxy setup, and it is known as mass spectroscopy or mass spectrometry. So which is mass spectroscope is basically used in MBE to monitor the mass of the gases inside the reaction chamber. So with this, by monitoring the mass of the flow of the gas inside the reaction chamber, basically the thickness of the film is basically monitored on the surface of the substrate. MBE system consists of a setup which is known as REED, RHEED, reflection high energy electron diffraction system. Okay, so the reflection high energy diffraction electron setup basically monitor the thickness of the deposited thin film. Usually high energy electron diffractometer is which produce the X-ray somewhere around 40 kilovolt is projected onto the surface of the thin film at grazing angle, and with the diffraction profile, basically the uniformity of the thin film is monitored inside the reaction chamber of molecular beam epitaxy. Dear student, please note that apart from all the basic characterization techniques or instruments used in the molecular beam epitaxy, there are also additional setup which can be used in molecular beam epitaxy. But it is not necessary that the additional setup, every system must have the additional setup. Usually there is also another characterization technique which is known as X-rays photospectroscopy, XPS, and that is which basically monitor the composition of the deposited thin film, is also used in conjunction or in attachment with the molecular beam epitaxy setup. So this technique I have explained in a simple way, but this technique is very broad and there could be a wide range of characterizational setup or even the characterizational setup, and even wide range of precursors pockets may be used inside the reaction chamber, and there could be many type of precursor that could be used in load log setup of the molecular beam epitaxy. So dear student, thank you for